started recording. We are live, and I can say welcome to Tools Workshop. On this day, I would like to talk with you about statistics. So, no, don't be afraid. It's not a math course, but just the basics for what we need to apply for sporadic issues and test instabilities in our scope. That means, like, OpenKA tests are a really good example. What I use as suggestion for a statistical investigation, mean value rule of 3. So let me give you an example. Let's try to actually look up example dynamically. So what we can do is we can just take a look for any failed OpenKA job, and let's find some issue as an example. Let's just start with the very first example. I didn't check that in before. So there's a failure in non-OpenQA test. It's failing in Firefox. I think this might serve as a good. So what happens here is that the HTML5 test should be rendered in the browser window. And oh, by the way, I forgot to switch off the webcam overlay. Do you clearly see my picture? Readable? Anyway, oops, sorry. Yeah, now anyway, I will switch off the webcam overlay. So it's readable. Right. So what is expected here is that the URL would be fully loaded, which would be visible by that reload button. But as you can see, the page didn't actually finish load. So the question is that sporadic issue, like, does it always repeat? For that, we have information like from the OpenKA Investigate tool, which automatically re-triggers on any unknown, not labeled issue. Which, it's not finished yet. I mean, this just finished 2 minutes ago. So let's give it a bit of time. Depending on that, we can judge, is it a sporadic issue or not? Also, when taking a look in the next and previous results, then I don't know, is it exactly here? What would you say? Is that, what kind of issue is that? Is it reproducible or not?
Indeed.
Yeah, talking about Firefox, I mean, there are some jobs where Firefox doesn't show up, like this one. That's an incomplete. So likely the test stopped even earlier. So that seems to be like very reproducible. So the chance is very high that if you execute a test like that again and again, then you will reproduce. In some other cases, maybe the case isn't that clear. So if you're looking into sporadic issues, then let's try to find another one. So this one is live. Oh, also Firefox. Okay, cool. How does this one look like? Doesn't show up in the last month. Now it does show. What would you say? I would say that looks to, yes, say.
At least the latest run just failed, so it might be reliable. Like, it's still very fresh. The first failure is just a week old.
Well, there was this one 14 days ago. Let's assume it would be the same one. And then there was one issue in between which did pass. So I would say at the very basic level, if we re-trigger, if we say there is an issue in Firefox, regardless if it's a product issue or test issue, right? If there is an issue in Firefox and we re-trigger one test and it passes, does this tell you that the issue is gone?
Well, I wouldn't think so because we're already seeing a gap between the failure and the passing one.
Right. So that's conducting one job to say, is it still reproducible or not, is not enough. Now the question could be, how many jobs do we need to run to check if the issue reproduces?
Wait a moment. So I think at this point it's important to really make sure that the question is consistent,
Yeah.
because if you ask the question, is a regression happening, then one passing test run typically proves the opposite, because regressions are not sporadic. This is a hard statement, but they are rarely sporadic.
Yeah.
Yes.
Right.
If you ask the other question of is this a sporadic failure, then the approach is a different one.
Yes.
So at this
Right.
point, I just want to say the question matters.
Okay. Very good. I mean, I try to pose with the let's say the most generic question, right? Which I assume many people ask, like, is it reproducible? Not even trying to distinguish. But you're right. One should say there could be the hypothesis that we have a clearly reproducible regression, which started in one of those builds, right? Is that what you mean?
Yes, exactly. The
Right.
point is just the question matters if you're searching for a regression, or if you're searching, or if you want to determine if something is a sporadic failure.
Okay.
Mhm.
Exactly. And for both of those, I would call those hypotheses. We can run experiments. And what I would like to present to you or discuss with you is the, let's say, the way how to conduct experiments which are very generic and which are not applying any knowledge or intelligence about trying to identify the or narrow down the real issue. I mean, if at all there is an issue with the Firefox module, right? So what we could think about is to say we could take a look into the log files, or we could, try to exclude all the modules which don't have anything to do with Firefox, and we can actually take a look into, what changed in the changelog. I mean, is Firefox in a new version here or anything like that, which is all good. But talking about the, let's say, the um, an approach which is agnostic to the specific issue, we can still derive something, which I would say we can still derive more information with the help of OpenQA regarding any issue in general. So Firefox is just one example. And at this point, we have those two hypotheses. One hypothesis would be, okay, we have, Firefox was okay in before, and we have a regression. Either since, let's assume that this, if at all, this is the same issue, then I would say we could have a not 100% reproducible product regression in Firefox since build 72.16, right? That could be one hypothesis. And a counter hypothesis could be that there was a sporadic issue present in Firefox already in before, just out of pure luck or coincidence. It doesn't show up in those results, but it was actually still there. Phoenix, do you agree with me that those would be two valid hypotheses? Or can we already rule out one from this observation?
Under the assumption that the test codes or that all of the experiments are staying the same, this is a
Yeah.
valid approach, yes.
Yes. Right. And to be more precise, it makes sense to say identify all the parameters that could have an impact. And then for each of those parameters, you can say, okay, you can conduct an experiment to say, take back those parameters to the last good and check, for example, 1 month ago, I mean, since then, we know for sure the product has changed, the build environment was changed, likely it was running on a completely different machine in a different data center at SUSE, probably. The test code has changed, the needle has changed, the settings have changed, and the moon phase has changed, right? So based on where we would most likely expect the source of an error, we could try to dig further. But let's try to stay simple. I would like to demonstrate two things at once. I would like to demonstrate you a really little script, which helps me a lot, which I call count fail ratio. Shell script, and as you can see, it's rather small, although it has a lot of some complicated characters. The only thing that it tries to do is run an executable multiple times and tell you, count the failures, tell you how often it failed, and also tell you a little bit more. I'd like to show you that. So, staying with that example that we had here, to simulate what happened here, what we can say is that we can count the let's start with something simple. We have a test, and let's say an OpenK test passing resembles the execution of the command true, which doesn't fail, right? And so we run that one time. The count fail ratio tells you we ran one time, we failed 0 times, the fail ratio is 0, plus minus 0%, because there was no variation at all. There's one additional message which it gives you. If you want to look it up, I already mentioned that in the topics that I wanted to discuss today. This is based on the rule of 3. This basically is a rule of thumb that is derived from how you actually compute a failure probability. We just executed an experiment once. What does that tell you about how that is representative of a bigger test set? It tells you there had been no failures, so we can compute the failure probability, but it is below 300%, which means that's just not sensible at all, so it doesn't tell you anything. Let me give you the counter example. So a test that we execute it once, it fails once. So what can we say? Well, we ran one, it failed one time. Fail ratio is obviously it failed in all out of all runs, meaning 100% plus minus no variation. Now, if we run that 3 times, that stays the same, right? We always fail 100. If we do that for true, the only thing that changes is the computed failure probability. Now we'll go into that very soon. I have written as a mock of a sporadic and a failing test, developed that count fail ratio test. I have written a command which is called fail once every third call. So what that thing does is, if we call it once, if we call it a second time, yeah, it passes sometimes and it fails sometimes. See? And it's reproducible. It fails every third time. But let's assume we don't know that, and we just assume it to be sporadically failing. Then, when we use count fail ratio, execute that, what it tells you is, well, it just counts the runs and it counts the failures. And yeah, we can see, oops, failed the first time. The fail ratio is 100%. The second time it didn't fail, so it doesn't count as a failure. That means the fail ratio reduces to 50%, plus minus 69. The third run, it also passes. It didn't fail. So the fail ratio is 33%. I guess that's something that you can stand, how that statistics is calculated, plus minus 553%. And let's run that again. We can see that we end up the same. So this is reproducible in itself. if we, let's do it 10 times. If we do it 10 times, then you can see that the fail ratio moves around a bit, but the confidence interval that we apply here reduces over time because we have a bigger set, so we are getting better with counting, and from that we could derive like, okay, if we would run that theoretically indefinitely, then overall what fail ratio would we expect. Now let's assume that would be a sporadic test. And there are two things which you want to do. One thing is to say, you want to know the fail ratio for sporadically failing test. Why do you want to know that? Well, only having a good estimate about the fail ratio, then you would be able to design a verification test for any potential fix. Okay? If you would have a sporadic failure and you say like, oh, okay, I know what the failure is, you're creating a new needle, or I don't know, adding a sleep one or something seemingly stupid, and then you run one test to verify. Well, that cannot work, right? Because by chance, that sporadic failure would also pass from time to time. So just running one test and having one pass doesn't tell you that your fix is effective, right? Does it make sense what I'm telling? So one thing that one should do is have an estimate of the fail ratio. And sometimes you can just count it in your head easily. I mean, if we assume that the issue, let's just take a look at those 10 tests, okay? If we assume that this issue is a sporadic underlying issue that was present already a month ago, what's the fail ratio then? Simple to calculate. I'd like to give the answer. What's the fail ratio if we assume that Firefox could have potentially failed at in any of those jobs? What's the fail ratio? I mean, it's just counting the failures divided.
3 out of 10.
Exactly, 3 out of 10. So with a 30% chance, Firefox would fail. If we assume the second hypothesis, that this is a regression which happens since 14 days ago, since build 72, what's the fail ratio then?
$75%?
Exactly, 3 out of 4, 75%. So that makes a difference when you're saying like, okay, that's let's say a test regression, right? So we did some changes in test and we broke it since that build. It doesn't always fail, but often. Then let's say rule of thumb, you don't need to run as many verification jobs to verify that the issue doesn't happen anymore after your fix. If you assume that there was an underlying sporadic issue where it failed 3 out of 10, then you would need to run more tests. Okay? So now let's say you apply a fix and you run your test again, like you do OpenQA clone custom git ref spec, and you call it 3 times, and your test always passes. So you resampled here by true. Then the computed failure probability is below 100%. Doesn't really tell you much. Let me give you another example. Let me start from the top of the page again. So you run 30 runs. And what you can see here, that they computed, so we run 30 jobs and it never fails that means that the computed failure probability is less than 10%. That's easy to calculate. It's the rule of 3. What it tells you is if you run an experiment and there are no failures, then the computed failure probability with a confidence interval of 0 to 5% being wrong with that assumption is that 3 divided by the number of runs. So sorry, inverse 30 divided by 3. Okay. So you observed no failures, and that means your assumption is that there is a chance of less than 10% probability that there would be any failure occurring still. Based on your hypothesis in before, that can give you an indication of how much you can trust those tests. And I would like to show you a recent example. So we had one ticket in our backlog where we, let's say, where statistics mattered. There was a problem that the OpenQA scheduler was overwhelmed with too many workers. So what we did is we simply removed some workers. We switched off workers. And then we had this ticket measured to mitigate WebSockets by workers and reverted. And the job was, because we stopped workers, the job was to revert that. It means bring back more workers into OpenQA. But we wanted to carefully do that. And in the process, you can already see from the scroll bar, it wasn't that straightforward, right? Because what happened is, Liv, you worked mostly on that ticket. You started with one worker, and then okay, there was a problem with bringing in the worker, and then we observed, let's say, a single test that looked dubious, at least, failed. Okay, and how did we link it? Well, Liv brought back worker 31. That job failed on 31. So the assumption was that this is not a generic sporadic issue, but this is an issue which is definitely linked to bringing back that one specific worker. However, we know that sometimes there can be other issues also in the iSCSI client and multi-machine tests, which are not the same issue. Okay, so we need to separate those hypotheses. So let me scroll down a little bit further. In the end, what we did, or gladly what Liv did, is do something like this. Very simple. A for loop. Do retry OpenQA clone job without reading the whole line. Who can tell what this is doing? What is this for loop doing?
Clone 100 jobs.
Clone 100 jobs. Thank you. And the result is this build here. And in the end, more tests were added here. And this is a realistic example because it shows you that real life isn't simple. Because the result was that many jobs were triggered and always be and there were multiple different failures, OVS client, OVS server, some canceled, some passed. So what's the what's the result of that? I think the result, Liv, tell me if that was right, but the result was we are not sure what to make out of that. Is that correct?
That's fair to say.
Yeah. So we found, okay, not everything is fully green. I mean, if everything would be fully green, what would that have told us? It would have told us like we are safe to bring back all workers. Well, the one thing which those results told us is we are not safe for whatever reason. We don't know what the reason was. Maybe we did something wrong in designing our experiment. Maybe all the workers were broken. Maybe the tests were broken. Maybe single workers. We didn't know at that. So yeah, spelling the settings wrong and all that things, that can happen. And Nick found another list of tests, like a long list of tests. So we found that there are some inconsistencies among workers. So what we saw like, aha, okay, there's one hypothesis which we followed, that maybe the IP forwarding is not properly enabled. And we found that at least that is not consistently enabled at all. So we came up with a change, and the change was applied, and then Liv did another set of tests. And now the result is different. I mean, there are obviously some failures. Judging from the numbers, I think those are not, let's say, wrongly triggered jobs, maybe, right? But there is the set of tests like server 001 and so on, which are like very green, very, very green. There is an occasional failure in between. There is a server, but the client is missing. So I don't know what to make out of that. But overall, what does it tell us? And we can even calculate that. We can say that whatever the reason for the failure is, the failure rate 4 out of 591, that's already a rather low failure rate, right? It's below 1%. And below 1% means it cannot be the issue that we had in before with broken IP forwarding. Because with broken IP forwarding, even if that is spread out over 10 workers, and we spread out tests about all 10 workers, what we would expect is 1 out of 10 failing, right? So let's assume that we spread out the tests correctly over all those workers. We can reject the hypothesis that we have the broken IP forwardings. But there's still some issue which, at least with the level of quality that we want to apply in this ticket, we shouldn't simply reject. So Liv looked into more detail and asked what's the plan, and Liv triggered another batch of tests, and what was found is, I don't know, Liv, could you share some details? So how could you identify where specifically the error was?
Well, what I actually did to make things a lot simpler is filter everything that's not a failure. Because at this point, the confident to passing ones are not interesting, and the incomplete looking ones are getting cancelled because of job settings, as it would say.
Right, so you would only look at failed jobs from this set, right?
Yeah.
And then, well, let's take a look. And what we can see.
A quick look is going to be enough to get an idea.
So this failed 3 days ago. Oh, wait, I see that. All failed on worker 31. And none of the other jobs failed. So we can say that the fail ratio on all the other workers was 0, right? Let's quickly calculate that, I can use my tool. So just a rough estimate, because I don't know exactly the number of jobs that were executed on on other workers than worker 31, but let me say that would be equivalent to running this script. What was the number? Let's say something around 560 jobs. It's true. And, we run that experiment. This is like on all the workers which are not worker 31. And what we can see is that, even if it continues, the failure probability is way below 1%. So, the chance of us being wrong, assuming that those workers would not produce any unforeseen error, would be around 0.5%, which I assume gave Liv good confidence to say we can enable all those workers except for worker 31. So what's the failure rate for worker 31? I don't know, because for that I would need to know the past ones. But I would say it's significant enough because, we found multiple ones. So it's not a single one, it's not a fluke. And that means that what Liv did is identify worker 31 as being problematic. And you enabled all the other workers in production and created a separate ticket about worker 31. Perfect. So,
and for completeness, I actually confirmed that every single failure was the same issue.
Right. So that's also good. Right, exactly, because just because an OpenGA job fails, we don't know if it's the same issue. And even if it fails in the same module, it doesn't have to be. So that's very good. So what's the failure ratio on worker 31? Again, we don't know that yet. I would say that's something that we can look into for that ticket, re-enable worker 31 for multi-machine tests. So now, who would like to give a hint? How can we work on that ticket? What do we need to do? Regardless about specific, the specific ticket, what do we need to do about the statistics? Or what should we do? Anyone would like to give us a suggestion?
Is it at this point still a statistics problem, or is it more with statistics we identified the actual issue and we are now going to resolve that issue problem?
It's about statistics, at least at one point. I'm going to tell you why. Because as a product owner, knowing the backstory, if somebody would work on the ticket and show me a single OpenQA test passing, I wouldn't trust it. I would say, I don't know, maybe it was only sporadically failing in before, so please run more tests. And again, this is not applying any intelligence about the selection of the test modules, or, of course we could run different variants, different products, like different test scenarios and all.
No, but we identified that the problem is now on worker 31. So
Yes.
Would you accept at this point a passing test run on worker 31?
A single one? No, because I'm not convinced that this is that we have a 100% reproducible issue. Because
True, yeah.
nobody told me the number of pass jobs on worker 31. If Liv would have told me all the jobs on worker 31 failed, then I would say, fine, not a sporadic issue. A single verification run passing would suffice. Right?
Yeah, I'm back into it. Yep.
So what we can do, what we don't necessarily have to do that, because in the end, if we are not working properly on the ticket, so let's assume we are just bringing back worker 31 back into production after applying what is presumably a fix. Don't know for sure. you guys would tell us, or our monitoring would tell us if we did it in the wrong way and there's still an issue with worker 30. Okay? But if we want to do a good job, what we should do is first understand the current fail ratio of tests on worker 31, which can be simply done. So, Liv, I think you created a ticket and you already gave a really good example. So this is how we can clone an existing job, which is then, it's a single test scenario. So, it's the open vSwitch scenario. Other scenarios might be different, but still that one showed a problem originally. So we can trigger a test on worker 31. And I would say what we can do is run that multiple times, let's say 3 times or 10 times. And based on that, we can compute a fail ratio. And based on the fail ratio, then we can decide how many tests do we want to run in a verification to be sure that we have actually resolved. So, we would need to run 2 test sets. One to know the fail ratio, like the original reproducibility of the issue, and another one as a verification for the fix. And I'm just giving you examples based on OpenGate tests, but I would say the very same applies to any kind of sporadic issue. Like if you have a sporadic issue in a unit test of UEM bot or something, then the same applies there. A sporadic issue that only happens sometimes cannot be verified with a single successful run, but multiple ones. And I showed you how you can get some indications how to, how many to run. I would like to reference. There's also the OpenGate test wiki, which among other things also mentions in the definition of done that verification runs are needed. I mean, this is maybe without knowing this wiki page, you already apply because reviewers of also insist for OpenSUSE would ask you for verification run. There are also some ideas here, for example, for structured test issue investigation as well as statistical investigation. And that, again, is just the very same example that we have shown you from the ticket, a simple for loop, which you can do. 469 also provided another nice shell script which you can use. I referenced the count fail ratio script that I've shown you for demonstration purposes here. And the good thing about this is that what you have is multiple tests which show up in parallel in one temporary build. So, what I see sometimes is that people do run multiple tests, but then they give a list of all the individual test results, which isn't really that helpful. More helpful to have a build like like a complete batch of tests, because here OpenGA simply helps you with counting. I mean, one could go fancy to say like OpenGA could count the fail ratio and all the things that count fail ratio does in here. Yeah, we could think about that. But the important point is, you don't need to count yourself. This box just tells you all those tests failed. So you have 12 out of 12 failures. Let me just check that. Right. So Liv did 2 different batches, both on worker 31. So actually, we know that we do have a 100% reproducible test issue. So in that case, yes. Coming back, what Phoenix, what you asked, I would be completely okay to say you have a single pass job, which shows me that this specific issue is solved. What does this like? This is also. Oh no, right. I get it. I did it wrong. Even better. So those are the complete results. So if you want to calculate the overall result, you can say 12 failed out of all those jobs. So you can say 12 divided by the sum of those. And obviously you can filter. And if you want to take a look into the individual failures, then this build view is also helpful. This is why I suggest use something like that. I mean, you can, this is just, you know, a customizable script line. You can use this script. There's also, I think there's also OpenGA clone set in the OpenGA repository itself. Need to look that up. But the important point is it gives you a build and then it simplifies count. So what are your questions or notes, or what are your experiences regarding statistics and in analysis? Any best practices you would like to share, maybe?
It's difficult.
Okay. Okay, so
no, it really depends on the problem. I mean, the easiest task that you can have is when you just run a couple of test runs, assuming that nothing changes. But one of the difficulties is that when doing statistical investigations, you're dealing with an ever-changing environment. So the assumption that nothing changes while you're doing a set of test run is often not met. That it doesn't make it like hopeless, but it makes it a bit more difficult sometimes.
right. So exactly. That's a good point. You have to keep in mind that one is always assuming a hypothesis. Okay. So for example, let's say in your daily review, you are encountering a failure like that one, right? I know that many people say, many people click that retry button. When you click that retry button, you must know that you have an implicit hypothesis in mind. Your hypothesis is that whatever caused the failure doesn't apply anymore after retriggering. Because if all the conditions would be exactly the same, then the error would very likely reproduce. Because in essence, effectively, we don't have any sporadic issue that just fails sporadically. The issue of sporadic failures is that there's always some system parameter which makes it more likely to fail. So why did it fail here? Maybe because the worker or the test or the product or the moon phase behaved differently. Clicking the retry button would lead to a pass drop if any of those factors do not apply anymore, right? So if it fails again, that this is an indication, not a proof, but an indication that likely one of the parameters which did not change is impacting it. So let's assume that you end up with a failure, even if it was running on a different worker, then that means that likely the worker itself is not the cause of the. If you reproduce the error, but it was the same build of the product, then maybe the same build is still a problem. But you're also running it with the same test code or an even more recent test code, and it still fails, means that very likely it's making it more likely that the regression could be in the test code because you're not running it with the old test code. This is why the investigate jobs could help you. If we take a look here in the list, then yeah, we can find, for example, this is one of the latest incarnations of an investigate job. it's an investigate job itself. We don't know what job it was originally investigating. This is why we have a setting OpenK investigate origin, and we have that one. So this job failed in system settings 5, so it's not the same issue as before. Without knowing the history, what we can see is that OpenK investigate is already trying to help you to answer the question, what is a more likely hypothesis? Okay? We can see that a simple retry, that is like equivalent to you clicking the retry button, except that, it doesn't override the production test result, but it's like separate. It doesn't impact like any tooling on board making decisions about the product releasability criteria. And it tells you, well, soft failed. So it didn't fail. It didn't reproduce the issue. So this is very likely a sporadic failure. It doesn't rule out the impact of the worker and all those things, but what it does rule out already, it's unlikely to be a problem with the test code or the build or a combination of those. I need to combine all those results because, even a retry does make it pass you. So you don't need to go back to the last good test to do. So that should help you a bit. If you don't have the OpenK investigate results, then, well, you need to at least keep those hypotheses in mind. But my experience, it's too hard to keep those in mind for anything that goes beyond a test that runs like for 2 or 3 minutes, right? For anything that takes longer, maybe I'm getting old, but I need to write the stuff down. Otherwise, I won't be able to remember, like, maybe it could be this, maybe it could be that and such, right? So, Phoenix, that's why I think structured test investigation helps here. This is also why we have a ticket template. You can use that template, but it's just a template. You don't have to. You can use your own template or anything that works. That's completely fine. But, this one should help you as a decision guideline to say, maybe the product has changed and what's the consequence of each of that? And then you can design an experiment around that. Janis, you asked, can you show again how you did run the script against the OpenGL results? I never did. I only simulate. I mean, what I did here is I simply simulated tests, which could be a unit test, which could be a test for the COVID-19 vaccine or anything. It's just simulating that there is true, which always is true. There's false, which is always false. And then there's bin test, fail once every third call, right? I only use that. And so I use count fail ratio. I don't think I ever used count fail ratio exactly together with OpenKA test. I used it to work on something like a sporadic unit test failure in the OpenKA test repository, right? Because, you are working much more with actual OpenKA tests than me. We in the tools team work much more with the software itself. So like a unit test of OS Audience or a unit test of OpenKA. Does that make sense?
Yep.
Okay, cool. Phoenix, did you want to, I would be happy to hear more from you. So what's your experience? You say it's hard. Any other suggestions that you can give to newcomers or to your colleagues?
Right. I think the guideline that you wrote there is a good starting point. It's hard.
Yeah.
It really depends because there are so many moving parts that just as one counter example, but it doesn't invalidate the approach at all. If you have a sporadic issue that happens at the time when SAC updates itself during the night, then you can run 100 test runs during the day and all of them will pass.
Right.
but they will fail when the infrastructure is being updated. So there are limits to it one, but as said before, the limits do not invalidate the method itself.
Exactly. So in light of that, the suggestion that I can give you is if a problem appears hard, then try to make it bigger. Okay? Just one example. If system settings 5 fails and it doesn't reproduce easily, and you can really not make head or tail out of that, then you can make the problem bigger, as you just stated, maybe it's something outside the scope of system settings 5 itself, right? Maybe this is related to the test harness around that. And what does the test harness mean? It could be the worker, it could be the network, it could be SCC, it could be all those things. And then you can follow up with each of those points. Maybe it helps to conduct a brainstorming, try to do it yourself, try to do it with colleagues, try to identify go wild with all potential things. I mean, in a brainstorming, in the first step, everything should be allowed. And you should mention the hypothesis. Maybe this is related to, SCC. And then maybe you can rule out that hypothesis and say, like, well, it could be SCC, but it's very unlikely that SCC is involved because, that's an open SUSE tumbleweed KDE test. We don't try to reach into SCC, probably. I mean, maybe we do because somebody built in, a SUSE only internal feature by mistake, and now system settings 5 is much slower because it tries to always reach SSC, which it cannot. And the crazy stuff like that is unlikely, but sometimes it helps to make problems bigger in scope. Okay, anyone else wants to share their experience or tell me that we all got it wrong? Yeah, bigger. Could you elaborate? Does it mean look for different perspective? Exactly. Try to think outside the box, the original box. Because many people try to, they would look at system settings 5, and then they have troubles to fix system settings 5, right? Because from the point of system settings 5, it looks like there's a real sporadic issue. But we don't know yet if this is really something specific to system settings 5. So you can look bigger. You can think, where does this test run? And just one little step to make it a bit bigger, to think outside, is, well, maybe it has to do with what had been running before. Maybe it has to do with the overall scenario. Maybe it has to do with worker. Maybe it's something that affects the whole build. I mean, did you take a look on the whole build? If now suddenly there are many more failures that show up, which are maybe of the same kind, maybe the whole build is broken, right? So maybe it's not system settings 5. Maybe it's not only the whole build is broken. Did you take a look into chat because somebody wrote today that download OpenSUSE.org is down, and then you don't need to take a look for specific problems, right? So all like that you can keep in mind. Maybe this test is testing too much, split test so that failure tell me exactly what is wrong. Yes, you can do that. However, I would say those are different approaches. That would already not be a generic, statistical investigation or problem analysis. That's already a way how to come up with a smaller reproducer or an actual fix for the issue, which are all good. But depending on the criticality of the issue, the good thing about those tasks is that they can be parallelized. If you can do that in parallel. Like, while you rewrite the test to make it smaller, you could ask OpenQA to run 1,000 tests over the weekend if it helps you in your statistical investigation. Or work together in a team with a colleague to do it. Right?
What you can also do is when you have a sporadic failure and you identified the point that you increase the failure rate. You know, as an example, I think this
Right.
is what the bigger picture means. If you have a certain pool from a network resource that fails every 3 times, then you can, for instance, run that 3 times in the test case and therefore increase the failure rate.
Exactly. That's a very good idea. Like if Firefox makes a problem and your assumption is that it's really Firefox, then you can run that part more often. Or let's say maybe you don't need to run the complete scenario in a loop, run within the test module that one part multiple times. Is that what you're saying?
Yes, exactly. Make the
Right.
painful point more painful.
But one more idea from the chat, one more idea. Everything since here is in term of green and red binary results. Collecting metrics and have tool to keep track of them could help too. Yes, that's true, but one has to be careful. The metrics only help if you know what goal you want to achieve with those. And this is why often there's the trap of people collecting metrics for the sake of it, to feed the buzzword. But there was no idea about how to actually make use of those. I mean, we also have metrics available in OpenQA somewhat, and there could be cool ideas how to make them more accessible. We also have metrics from our infrastructure monitoring and such. But always when we do that, we are adding those because we want to answer specific questions. Okay, cool. Thank you guys all for your interest and for your additions here. I would be happy to learn more from your feedback also later about this topic. And with that, I would like to close the session. For the next week, we haven't planned a specific topic yet, so we are open for proposals either from the list below, or if you want to cover a specific topic, then I would be happy to hear about it. Until then, thank you for attending and see you later. Goodbye.